Okay, we are recording.
Okay. Good afternoon, everyone. Thank you for joining us. I'm Jenny Shanker from the Michigan Center for Student Success, and this is the second in a series of 3 webinars presented by the Dana Center for providing co-requisite supports to students in math pathway courses. We're excited in Michigan to be part of the Dana Center's Math Pathways to Completion project, which we've titled in Michigan, The Right Math at the Right Time. And we're kicking off some co-requisite work with some of our institutions. Excited to learn more about providing co-requisite support for statistics this afternoon. So thank you very much, Marcus, for being part of this, and for Paula for arranging these webinars for us. And I'm going to turn it over to you now.
So hi, I'm Paula Tolley. I'm the Systems Implementation Lead for the Charles A. Dana Center. So we work closely with Jenny, and we also have Richard, the consultant, on the line. And I just want you to know I'm going to keep you muted during the presentation just because it's being recorded. We don't want any odd sounds. I even have dogs in the background, so I'll have mine muted too, because you never know when they're going to want to speak as well. We are honored to have Dr. Marcus Pomper on the line. He serves as the Dean of the Division of Math and Sciences at Roane State Community College in Tennessee. And previously, before this position, he chaired the mathematics department at Indiana University East, where he implemented several online programs and successfully grew the online programs. Currently at Roane State, he is a mathematics faculty and has led a successful implementation of co-requisites for statistics. And we've seen him do many presentations, and he has a lot of good information that we feel is helpful to the field. You'll actually recognize we shared a couple of things if you attended the co-requisite workshop last fall in Michigan. You'll see that we actually shared a couple of his resources. So I am going to turn it over to Marcus, and thank you so much for joining us for this webinar.
Thank you, Paula, for the introduction. My name is Marcus Pomper. I'm the Dean of the Math and Science Division at Roane State Community College in Tennessee. Just one item about if you have questions, please interrupt me by typing in the comments box, and Paul will then tell me what has been asked. I can't see your comments as they're being typed, so I'll need to rely on her to convey what is being asked. So just a little bit about Roane State Community College. We're located in East Tennessee. So if you look at our logo, it represents the outline of the 8 counties that we serve. That's an area west of Knoxville. Knoxville itself is not part of our service area. Knoxville would be in this triangular area that's between the S of Roane State and the logo itself. That's where our service area ends. We enroll about 6 students. We have a campus in each one of our counties, and so that makes 8 campuses where we have general education classes, including math, and we straddle 2 time zones, which is also an issue that makes scheduling sometimes very, let's say, interesting. The westernmost 2 counties in this map are in the central time zone, and the rest are on Eastern time. And just a little bit about the history of remediation at Roane State. Before fall of 2015, we used a model of remediation that is based on the Emporium model. So it consisted of self-paced modules. They were taught in my math lab. 5 of those modules, students had the options to spread those 5 modules out over 2 semesters. So if they wanted to do that, they had to complete 3 of those modules in the first semester and the remaining 1 or 2 in the subsequent semester. And what I've done here is I've downloaded from the internet a picture of what an Emporium model classroom looked like. Ours looked similar, just not as big, but about just as enticing as this one here. Looks. So just a little bit about the advantages and disadvantages of prerequisite remediation. One item that we found, that our faculty found, very advantageous was that when it's successful, it will prepare the students for all entry-level math courses. So the student that takes the sequence of remedial courses, they will be ready for the algebra sequence, they will be ready for statistics, they will be ready for math for elementary education, and whatever other entry-level math courses we might have. And the flexibility obviously allows the students to complete the course in less than one semester. So a student who may need just a little bit of review can browse through those sections in just a few months, whereas others can take up to 2 semesters. Then it requires very little teaching. It's self-paced, so the students use the modules and the help that's available in my math lab to go through those sections and those modules and ask the instructor when needed. And most of the time the students chose not to do that. So we basically paid a minimally credentialed instructor, usually a person with a BS in math, to sit in front of the room and wait until somebody walked up with a question, which very rarely happened. Occasionally proctor a test, but that was about the engagement that we encountered in our model. So that one advantage is also one of the disadvantages, the last one that I've listed here, namely there's some sort of a risk for instructor apathy. And obviously the other ones are great risk of procrastination on part of the student. It's self-paced, so you might as well wait and do all your math in the last week before Christmas and try to get it all done that way. And we know that that doesn't work. So, and that of course leads to low completion rates. But so those are the advantages and disadvantages that the math faculty discussed as we were getting ready for this new co-requisite remediation project. But there's one item that I believe weighs, oops, let me go back here, oops. That goes even further than that, is there's a little bit of a personal bias. Namely, we're all math faculty, right? We went through all the math courses probably without ever failing a single one of them. So we went through all the design sequence of courses in the way it was made to be taken one after the other. This is how we learned math. And therefore we infer that this is how everybody needs to learn math. And my realization after going through this remediation or this switch from prerequisite remediation to co-requisite learning support is that that's not quite true. Just because we learned math in this way doesn't mean that everybody must learn it in the same way. So here's a little bit to, not really a poll, but a question for you. What are your biggest concerns as you're moving from prerequisite remediation to co-requisite learning support? And I have a few possible answers here, and if you have others, just let me know and let me type and type in your answer box or in your chat box. What are your biggest trepidations when it comes to switching from prerequisite to co-requisite learning support? And Paula, if you would let me know what the answers are, please.
So we're going to have pressure. There's only a couple of you on the line. We know this is being recorded, but if you could type something in there and I'll pass it on to Marcus. And since we have such a small group, you're more than welcome. I don't see anything coming through, but you're more than welcome to also, oh, here we go. Concerns towards expectations in the college level courses.
Could you elaborate on this a little bit? Maybe unmute yourself and let me and speak to it.
Well, sure. I think I don't teach math, but I know that one of the concerns that I have heard expressed from faculty is that the co-requisite remediation will cause the college level course to will kind of lower the rigor of the college level course. And that's been a concern for some faculty here.
Yeah, that was one of our concerns as well. So I certainly empathize with you there. Are there any other concerns? Anybody else that wants to share their concerns?
So I see a staffing. There's a concern of staffing is going to be an issue. And then also concerned that students would not want to take more than one class. It costs more money.
Mhm.
And since we have a small group, we just had somebody join us. If you have any concerns about moving from prerequisite to co-requisite, support. If you want to type that in the box, I'll relay that to Marcus. Otherwise, I'll let you go on, Marcus.
All right, so let me just give you a visual perspective of what our prerequisite remediation looked like prior to us switching to co-requisite learning support. So we had two possible courses for our prerequisite learning support: Math 0891, which was the first one in the sequence, and students who completed that successfully with all the 5 modules in it, they were allowed to go on to a college level course. So this is shown here with the Math 1530 course. And those who needed to go and complete the last few modules, they were allowed to go on to a second course, this one here, Math 0892, complete those missing pieces, and then go into a college level course. So we created essentially 2 pathways through this remediation here. And our hope was that students would go through this sequence of courses the way we intended and pass. But whenever you do a plumbing project like this one here, you have leak points somewhere along the way. So we have students obviously that withdraw or fail the first course, or they complete the first course successfully, but then don't come back for the second one, or they withdraw or fail in any one of those other courses. So what we get at the end, of course, that's what we're interested in. That's what we call the success. Now, I've followed one cohort of those students through 3 semesters plus a summer of coursework, and asked myself, how many of those students actually complete a college level course at the end? And well, the great success rate was 20%. 20% follow this sequence of courses the way we've designed it. And now we have all these puddles of water at the floor. So we send the janitor in to clean it all up and allow the students to do course repetitions. And well, we see that about 2.2% additional of the students complete a college level math course if they need to do a course repetition. So taking those 2 numbers together, that's 22% of a success rate. 1 in every 4 or 5 students that start out with us complete a college level math course if they follow this sequence of prerequisite remediation. And that's what I call the leaky pipeline. And I think it's time to call a plumber. So let's go on to our next poll question is, in your prerequisite remediation pipeline, what do you think you leak the most students? Where do you lose the most students? And if you want to type or speak up, either one is fine. A small group. Do we have any answers, Paula?
Not yet. I'm looking to see if, oh, here comes one. During remediation.
Mm-hmm. Okay. Yeah, that is probably, during remediation or simply in between, that the students somehow successfully complete one of those courses, but then don't come back. So that's kind of where we've seen the most attrition in our program, but yours may be different. One thing that I've heard a few weeks ago at a similar webinar is that somebody said, well, our college level course has a 90% completion rate, and that may very well be the case. However, it's 90% of the students that get to that point, right? So what you do with the people that start out, but then you lose them somewhere along the way. So that's one item of consideration that I'd like you to consider if you believe that your college level course has a pretty good success rate. It's where do you lose the students on the way there? So going back to Rhone State and our history here, our plumber for our leaky prerequisite remediation pipeline came in the form of a mandate from our governing board, from the Tennessee Board of Regents, which in its great wisdom announced that, first of all, community colleges will stop offering standalone learning support courses in math, in reading, and in English, and that all the learning support courses will be linked with a college credit-bearing course, co-requisite, prerequisite, preferably in the discipline. So for math, the preference was to link that course with a math course. In English, the remedial writing course was preferably to be linked with the Composition 1 course, and so on. And that was announced by our governing board in fall 2014. And oh yeah, by the way, the implementation date is fall 2015. So that didn't really leave us very much time. It left us less than a year to get ready for this, which is the reason why we went all in the first semester in fall 2015 without really having done a pilot of some sort in, say, in the spring prior to that. So let me talk about how we went about designing our co-requisite approach. So our main general education math course is probability and statistics. The course number is Math 1530. And we paired that with a learning support course, Math 0530, which is called Statistical Principles. And the English department did the same thing. They paired a reading course with a general education course in the humanities called Great Works. And similarly, they paired the course Writing Principles together with their Comp 1 course. And I'm going to talk about math, but this is the process that we went through in two separate divisions here for 3 different subjects. So for math, the way our course is set up is the college level course is Math 1530. It's probability and statistics. It's 3 credit hours. And this course is the same for students with or without learning support needs. So one section of Math 1530 may contain some students that have learning support needs and other students that don't. So it's a blended course. And that is one of the ways in which we ensure that the rigor of the college level course is not watered down. The requirements for the course is the same and remain the same, even though we have now students in a section that have a co-requisite learning support need together with it. What we had to do is that the sequence of the topics in the course Math 1530 is prescribed because it's paired with a remedial course, with a co-requisite learning support course, Math 0530, that also has 3 credit hours, and it contains students from several different sections of Math 1530. So those students in those learning support courses, they're also blended. They come from different sections of the college level course, Math 1530. So in order for this all to work together, we very tightly control the sequence of the topics in both of those courses. So this is kind of what it looks like here, is each instructor gets a timetable that shows what topics are to be covered on which day of the semester. So on day 1, day 0 is rolled into day 1, but on day 1, students in the college level class, Math 1530, cover sections 1.1 and 1.2 of our statistics book. Whereas the students in the Math 0530 course talk about whole numbers, place value, rounding, estimating, a little bit of problem solving, and expressions that have variables in them and how to evaluate them. So again, I said, we choose a doubly blended approach for our scheduling. So a student that has learning support needs may choose any one of the Math 1530 courses that are offered. So here's a sample of our timetable of our schedule from one of our larger campuses. Pick any one of those courses that are on the left side, and then for the support course, pick any one of the courses that are on the on the right side. As long, of course, as there's room in the class. We don't allow this for online courses, for online Math 1530 courses, or for accelerated courses, because obviously in an accelerated course, the sequence of the topics doesn't follow this common calendar. And obviously there have to be open seats available in the section. So just looking at the topics of our 1530 class, it starts out with graphical representation of data, descriptive statistics, measures for the mean and standard deviation, variance. Then in the middle, we have a little bit of probability. And then the last third or so of the course is inferential statistics. We're constructing confidence intervals, hypothesis tests, and linear regressions. And the topics in the learning support course that go with it, Math 0530, they are timed and chosen so that the topics match the topics of the Math 1530 course. So they include the basics of fractions, of decimals, of percentages, how to convert from one to the other. And yeah, they're chosen so that the remediation happens just in time for the parent course for the Math 1530 course. So a typical learning support course that would look like this. We've provided a guideline for the instructors on how to structure their courses. So we asked them to start with what we call a mini lecture, a lecturette, maybe 10 to 15 minutes in length, where they review the material from the statistics course, and they explore some of the key aspects of the statistics course. And that's then followed by individual practice in my math lab, but we ask the instructor to stay involved with the student. So the instructor during this practice can't sit down and read the newspaper. They are asked to stay with the students, to work with the students, to walk around the classroom, check what the students are doing, use pencil and paper to guide the students to the problems where they have difficulty with, and so on. And occasionally, not very often, but occasionally, this support course also contains some aspects that one might find in a first-year seminar course, like notebook skills, or checking whether the student actually has a calculator, telling the students that they can check a calculator out at the library at no charge for the duration of the semester, and how to, maybe discussion on study skills and similar aspects. So a little bit of learning support is also included in this course. So here's how we developed this approach. So we assembled a team of 4 people, 2 senior math faculty members, 1 junior math faculty member, and 1 staff member from the Learning Center. And they spent essentially the end of the fall semester and then most of the spring semester into the summer in order to develop this course pair. So in the fall semester, they convene meetings with the entire math faculty, in informal meetings to determine the actual format of our remediation, because we were not told how to do it. We were just told to choose whatever method we think would work for us. And then beginning in January of the spring 2015 through basically the middle of the summer, they had bi-weekly meetings and developed the course. And here's kind of the schedule that they've settled into for those bi-weekly meetings. So initially they decided on the day-by-day schedule for all the classes. So that was done at the beginning of spring 2015. And then in what followed, they went through it class period by class period, and they used back mapping strategies to identify the likely missing skills in each one of those, in each one of the topics of the college level course. And then they planned activities and exercises that they thought would support the anticipated missing skills. And then between the meetings, they didn't sit idly. They actually did the developing of the exercises. They chose, for the most part, exercises that were already available in the Pearson product to choose from. In many cases, however, they found that those were not suitable, so they developed their own. So they started to author their own questions in Pearson's MyLabs Plus and use those because they thought they were better suited for what they had intended for this program. And then they wrote the lesson plans for the mini lectures, they developed quizzes, and then at the next meeting, they reviewed each other's progress and went on, restarted that process for the next class period. That was a pretty intense, work for those faculty and the learning support. And as dean, I had to intervene a few times when they started to fight and to get mean with each other. But that's what you can expect, in this kind of a situation. So anyway,
may I ask a question?
Sure.
You might, never mind, you're talking about it right now, the training manual. Didn't these faculty come up with a training manual that all faculty could actually use? And I jumped ahead, you're going right there, so.
Okay, so yes, thank you. So they did come up with a training manual. So by July 2015, they had completed all the assignments in my math lab, and then they created this training manual that was used for all full-time and for all adjunct faculty. And it included the timetable for the Math 1530 course, for the statistics course, and lesson plans for the support course. And during the in-service activities in August 2015, they discussed that at length with the faculty. And I'll show you in a moment here an example of what this training manual encompassed. So here's for the day 11 of Math 1530. So that's the introduction to probability distributions. It covers discrete and continuous random variables and the binomial distribution. So for binomial distribution, a typical problem is a coin is tossed a certain number of times, say 10 times, and the question is, what is the probability of getting heads up at least 4 times in this process? And we ask all of our students to have a TI-84 calculator, and it has those functions, binomial PDF and binomial CDF, in order to help with those computations. So my question for you here is, given those topics here, is what challenges do you think your students would encounter in this class? So this is not your first time teaching math or teaching statistics, I suppose. So using your intuition and your experience from teaching those courses, what do you believe are the most salient topics that should be covered in a support course for this particular class period?
So I see inequalities in the chat box.
Mm-hmm. Inequalities definitely are important, because if you're familiar with the TI-84 calculator, the binomial CDF function, cumulative distribution function, only computes probabilities of the form less than or equal to some number n, but not the other way around. So if we talk about at least 4 times up, we have to switch to the opposite event, right?
So that's some additional comments, the calculator functions and the complements.
Exactly, there we go with the complements. So this was my poll here, and let me just switch through this. And here's our mini lecture for that day. So the objectives are identifying probability distribution, distinguishing between discrete and continuous random variables. So those items were not mentioned, but that's what our faculty came up with. Translating from words to equality and inequality symbols, and to write the complement of an event in words. So the last 2 were items that were suggested by the audience here. So thank you for helping me out here. So, and these are examples of the lesson plan that we gave to that we included in our training manual. So the first one here is identifying probability distribution. So we give something that looks like it might be a probability distribution, and we provide step-by-step guidance as to what the students need to do in order to determine whether or not this table here, either one of those two tables, represents a probability distribution. So add up all the probabilities, and if the result, if the sum of the probabilities come out to be 1, then we have a probability distribution, and otherwise you don't. And secondly, distinguishing between discrete and random, discrete and continuous random variables, we give several examples, right? So the number of broken eggs in a shipment versus the amount of flour used per day at a pizza place. And finally, going to the inequalities and the equality symbols. So we have several examples, and I really like this, the way our faculty have developed this here by saying X is at most 6 out of 9, and they've made a dividing line between the 6 and the 7, and suggested to the instructor that they circle from 0 to 6 like this, and as the complement event of the event, underline the 7 to the 9. So I think that is a very useful way of going about this, and there's a whole long list of problems that is like this in our lesson plan. And then here we got writing the complement of an event is also included, right? So switching from X at least 3 out of 9 to switching to X is at most 2 out of 9. All right, so other examples of how those two courses interlace. The focus of our Math 1530 class, of the statistics class, is reading and understanding, say, statistics that's presented in graphical form. And then My Math Lab, or My Labs Plus, is what we're using. Those questions simply require the student to interpret a graph and then provide an answer to a problem. Now, in the learning support class, what we do is we guide the students through the parsing of the problem. And we prompt them to give additional intermediate answers before they get to the final answer. So here's an example of how that comes about, right? So here is an example that we have created in My Labs Plus about a polling company that reported that a certain percentage of adults out of a total 1,018 report cell phones are annoying. Now what we've done here is we're asking our students to walk through the process and first of all calculating the exact value. What is 29% of 1,018? Right? And then we prompt them to answer, why is this not the final answer? And then we ask them to round and provide the rounded answer as the final answer. Whereas in our Math 1530 class, if I may switch to the corresponding assignment or a corresponding assignment in the Math 1530 class, here we just give the total number, say, of books in the library, and we give a graph over here and a percentage of some sort of category of books in this library, and the students are just prompted to find the final answers without being asked all the intermediate steps. So we've designed all those problems to walk the students that are taking the learning support class through all the steps in the problems that they'll likely encounter and guide them to finding the final answer. Okay, so here's another problem. What is the probability that there are at least 6 heads in 8 coin tosses? So that's similar to the problems that we had before. And the learning support course then talks about what is at least and what's the opposite of that. How do we convert from percent to decimals and vice versa? And just one more way of how those are correlated. We look at hypothesis testing. And so the statistics course looks at identifying the necessary test and all the pertinent information that is needed to answer the question, to use the TI-84 calculator to determine the test statistic, and then to interpret that test statistic and answer the initial question. Whereas in the learning support course, again, what we do is we provide very detailed guidance for students as they go through the problem solving test, and we review the rules of probability and the p-value and what the rare event rule is, and so on. So the learning support course provides more guidance to the students and more review as they're going through that course. Okay, so again, one more item for this time for correlation and regression. This time here in our learning support course, this is when we introduce slopes and lines and linear relations. So we introduce that just in time when it's necessary for the students to actually use it in the parent course, in the statistics course, namely once we get to correlation and regression.
So Marcus, real quick, so it seems like the level of support or the level of the scaffolding of the questions in the support course, to get to that level, did your faculty have to kind of design most of those lessons, or did you find adequate support in My Math Lab with some of those scaffolding of the questions?
At that time, we did not. A few weeks ago, I was at ICTCM and talked to Pearson representatives, and they're developing courses. They're developing material and books for learning support. But at that time, when we were developing this course, these things were not available. So we used instructor-designed questions to walk the students through the steps. And I believe if I go back here to this, no, this one actually was this question here apparently was available. It's 1-229, but the majority of the questions that we had developed were instructor-made questions. So they were edited by our instructors and created by our instructors with all the intermediate prompts in between.
Thank you.
So one thing that we found very helpful, by the way, was to ask the students a question about the text of a problem. So, and to link that with a variable. So, for example, if the text of the problem said 1,037 teachers were interviewed, and whatever, something was found about them. The first question that we had is, how many teachers were interviewed, ? And then the answer starts with n equals, and then an answer box. So having that n equals part, and then the answer box, in conjunction with the question of how many teachers were interviewed, that proved to be very helpful in guiding the students through the solution process and parsing the question for the important information. So here's a little bit of survey data. We've surveyed our students and asked them what they thought about the course. And one of the prompts for the question is that the material that was emphasized in Math 0530 was well chosen to support my areas of weakness in Math 1530. And we have about a third of the students that agree with the statements, and another third, or a third that strongly agrees, and a third that does agree with the statement. The remaining third is either neutral or disagrees, or even strongly disagrees with the statement. And likewise, we got this question: overall, my performance in Math 1530 was improved by the assistance that I had received in Math 0530. And we have, quite a few students, more than a third, that strongly agrees, and then a little bit less than a third that agrees. So together they make about 2/3 again. And the remaining 1/3, more or less, is either neutral or disagrees with the statement. So now the question is, how do we measure success, right? How do we know whether that model works or not? And really, as you're designing your own, what I would do is I'd like to encourage you to find out, to identify ways in which you want to measure your success. So here's one way in which we measured our success is we've looked at the completion rates of those two courses of Math 1530 for students that have learning support needs, yeah, and those that don't. So in Tennessee, the learning support need is determined by the student's ACT score. That's pretty universal because in Tennessee, every high school student has to take that test at some point in their career. So it comes in as an easy placement test for us, and that's how the way we determine our placement. And we still would have, of course, withdrawals and failures, but the successes are quite amazing. So this, what we have here is in the first semester that we've tried it. So that was fall 2015. The reason why I haven't updated that is because I wanted to show is what happens in the first semester. What can you expect? And the success in our standalone Math 1530 class, 65%, right? So 65% of the students that go through that Math 1530 class that don't need learning support pass it, whereas 58% of the ones with learning support pass it. So it's somewhat comparable. What we've done over time, we've tinkered with those courses and we've increased pass rate. Right now we're close to 70%, a little bit more than 70% for these students that don't have remedial needs, and a little bit less than 70% for the ones that do have learning support needs. So we managed to get them closer together and to increase both of them, which is kind of nice. Another way of looking at measuring success is asking yourself, well, how many courses do those students complete in their first year? From how many of those courses are successful, and how many are attempted but not successful? And in the year before we went to co-requisite learning support, so that was fall 2014, spring 2015, we got that they, on average, complete about 12.6 hours passing and 3.4 hours not successful completion. And then in the year thereafter, both of those numbers went up. So they attempt more courses, quite a bit more courses, and they pass more, and but they also, the number of unsuccessful attempts also goes up a little bit. Another way of looking at that is only the same metrics only for college level courses, and we see somewhat similar pictures, and so I'm not sure which one of those two metrics is suitable for you, but the reason why I'm providing those here is simply to give an idea of what measures you might choose in order to measure your success. So let me get some suggestions from you. Is what other assessment metrics would you suggest might be useful for in your situation?
I see grade distribution.
Mm-hmm.
I would maybe add retention.
Retention, yeah. So fall-to-fall retention is a very valid measure of success. The reason why I didn't choose that for us is because typically an institution has more than one retention initiative going on at the same time. So if you have several retention initiatives, say if you implement a first-year seminar and at the same time implement this co-requisite remediation model, you don't really know which one is attributable to what. So when I agree, retention is important, you may not be able to isolate retention in this way. You may not be able to attribute it simply only to the co-requisite remediation. Do we have other suggested metrics?
I don't see anything else in the chat box.
So that gets us to the end of my presentation.
Wait, Marcus, one came in.
Yeah. Student
demographic background as well as other ways that students participate.
Say that again, please. I didn't.
Student demographic backgrounds,
Uh-huh.
as well as other ways that students participate.
Okay. Would whoever wrote that maybe care to unmute themselves and talk a little bit about it?
I see that he's unmuted, but we can't hear him.
Oh.
Okay, I don't know how to unmute. Let me see. Yeah, it shows that you're actually not, it just shows you don't have a speaker, actually, because it doesn't show you're muted or unmuted.
Okay. So yeah, I mean, one item that I would encourage you to do is to look at the data from various perspectives. So including socioeconomic factors. You're using ethnicity. Looking at the data from all those perspectives will give you ideas of where you might be losing students and how you might improve your success on this program. So, you know,
And there's an additional comment too about, are they actually active in other programs?
what is meant by in other programs?
Hang on, we see some typing. As he's typing, I know one of the comments that I think kind of lends to this, you know, since you're teaching them also some of those study skills and how to be a student, and oftentimes we see, you know, that they're becoming better students in other courses as well. So, oh yeah, so do they work in study groups outside of class, for example? So are they expanding their learning outside of the classroom?
That's
how to be a student.
That is probably a very good metric to see how this intense interaction with the student will help them in the future, or will help them with their study skills in general. So getting the students to work in study groups and teaching them how to do that and how to make friends and how to engage with one another outside of the classroom, that's a very valuable skill. And having the students for 6 hours, right, per week in this kind of a setting allows for you to encourage that and to work with that. So yeah, thank you.
If there's any other questions, if you want to ask Marcus, you can either unmute yourself or feel free to type in the chat box.
I have a question, if that's okay. So do you have for your for the co-requisite class, your 0530, is that taught in a computer lab?
It is.
Okay.
It is, yes. The classrooms that we have set up for that are computer labs, but they have a projector and a whiteboard as well. So for the part of the mini lecture, we encourage the instructors to use both of those, use the whiteboard, use the projector to discuss those items that are on the lesson plan for the mini lecture. And then once that is done, the students break into, sometimes they break into groups, sometimes they work individually. That depends on how the instructor would like to set that up. And the instructor moves from either student to student or from group to group and discusses how to do those problems in my math lab. Yeah.
Gotcha.
Yeah.
Okay. So is the My Math Lab, so they have two separate My Math Lab assignments then, one for the support class and then one for the regular class?
That is correct. But the way we've set that up is that the student only pays for one My Math Lab key.
Nice. Okay. And then just one more quick question. So do you, how does their grade work? Do they get a grade for the support class, or I'm sure that's their first question.
And I don't have the slide here, but obviously there are 4 possible combinations, right? They could fail either one of those classes, or they could pass either one of those classes. So if they pass both, we're very happy, and the student is happy. If they fail both, we're sad and the student is sad, and they have to repeat both of them.
Okay.
If they pass the college level class and fail the support course,
Mm-hmm.
we wave our hands and we say, well, it's good enough. You got general education credit. You're done with your math. We'll just pretend that the math 0530 didn't happen. It's still in their transcript, obviously, but we don't care at this point.
Okay.
About it. And the other scenario is where they pass the support course, the math 0530, and fail the 1530 course. No, wait a minute. Yeah, where they fail the 1530 course and they pass the 0530, in which case they only need to redo the statistics course, the probability and statistics at the college level.
Okay. So on their transcript then, do they have a pass-fail grade for the support course and then a letter grade for the other one?
It's actually, for us, it's a letter grade for both of them.
Oh, okay.
But your internal policies may dictate otherwise.
Yeah. Okay, cool. Thanks.
All right. I think, Richard, you had a question.
Yeah, I was just wondering, Marcus, in the couple of years that you've had to, to test this out and do it, what were the surprises that you faced, or the things that you had to tweak and change in order to be more successful?
Well, in the first semester, our biggest challenge was to get all instructors to adhere to this new schedule. And that was a big change, because previously we didn't have that. And we had a few instructors who didn't get the memo, right? And now you have to adhere to this new schedule. So they liberally, change the topics around, which you can do to some extent in this course, right? And they didn't realize that the students that are in the support course hear things being talked about that they've never heard before. And so that required a little bit of intervention on my behalf as a dean to say, listen, you have to follow this common schedule. It's new rules, new method of teaching it. So that was probably the hardest part in the first semester.
Mm-hmm.
Then I was somewhat positively surprised by how well it went. You've seen our success rates. We went from, say, 22% over the course of 3 semesters with this complicated pipeline of prerequisite remediation to almost 60% in the very first semester, and now we're almost up to 70% in success rate. So I was surprised by how well that went. We've, over the years, it's been 3 years, so we've made some minor changes to the training manual, and we've also looked at both of those courses a little bit more holistically, and we looked at what could we suggest to our instructors to do in order to incorporate various learning styles. So last summer we had a group of faculty that only looked at making suggestions of incorporating activities for kinesthetic learners in the Math 1530 course.
Mm-hmm.
That was included in the training manual. And then who knows what they're going to come up for next semester. But all those relatively minor little ideas that we've included there, they probably contributed to the increase in success rate.
Yeah, great. Thank you.
Did that answer your question, Richard?
Yeah, thank you.
Marcus, you might have stated this earlier, but so with the support course and the credit course, you could have different teachers. They might not have the same teacher for both courses. So are your credentialed people still teaching the statistics course, and then both those who have the master's and then those who have the bachelor's can teach the support course?
That is correct. So we're, Michigan, I believe, is North Central, if I'm not mistaken, as your accreditor. So we're in SACS territory, and SACS is very, very strict about their credentials and how it's documented. So faculty with a master's degree, at least a master's degree in mathematics, they're the ones who are teaching the college level statistics course. And the support course is not considered a transfer course. So the person with a bachelor's degree in math, in engineering, in education can't teach that type of a course.
Are there any other questions while you have Marcus on the line that you would like to ask him for his infinite wisdom in implementing Co-Requisite?
I wouldn't go so far as to describe it in infinite wisdom, but my email address is here on the screen. So please feel free to email me if you have any questions, and I'll try to get back with you and answer your questions if you do have any. But anything else, while I'm here, I'm happy to help you with.
I actually have one more question.
Yeah.
Do you ever get, so I'm at Washtenaw Community College in Michigan, and we have a lot of students asking for overrides constantly, daily. So I'm just curious, out of your group of students that have less than the 19 on the ACT, I mean, do you grant them any overrides, or is that just an automatic no and they have to take the support class?
It tends to be an automatic no. What we do is, if a student comes in with transfer credit, say in Math 1530, in college algebra, so they come in, they've taken in a different state, they've taken college algebra, or they've taken in a different state even the remedial course sequence. We tend to allow that. So we tend to waive the requirement for those types of students. But other than that, the answer is no. So.
Okay, that's what I thought. That's
welcome
probably
to my world. I mean, this is at the beginning of the semester. This is all I deal with is phone calls from Stroud students that don't want to take that, and try to find a way to get around it.
Yeah, thanks.
Mm-hmm. Right. Any other questions?
And if you don't have sound, feel free to type it in the chat box and I'll relay it to Marcus. And this webinar it is being recorded. So Jenny Shanker will post it on your website where you can go back and reference it and share it with others. We shared a sample calendar from Marcus back in the fall, so we'll post that again. And if you need any other supports, just reach out to me at the Dana Center or Jenny, and she'll direct you to the right person. And you have Marcus's email address right there as well.
Great. Thank you.
Thank you very much.
All right. Well, thank you, everyone. You have a wonderful rest of your Monday afternoon.